Today we'll look at the mathematical function. For the mathematical function to understand it, you need the concept of the variable, and the concept of the variable is explained in the variable video, and the link for that I put in the description of this video. So let's look at the variable. We have something like an x, right, which is the variable or a sign for the variable, and we have a machine. You can think of a function as a machine. Well, let's draw it a bit bigger because we need a big machine. Okay, let's draw it big. Okay, that's good. So now the machine can be anything, right? You know, machines, the factories, they have machines and they put raw material on one side and you get something else on the other side, right? So let's think about a machine, like very simple machine. You have something like a scissors, right? And the scissors cut the raw material, and then you have like a pounder from above that pounds whatever you put inside, and then you have like a water fountain that waters whatever comes inside. And let's see if we put something inside, what happens, right? So we have the x, and the x is now a little bit cut by the scissors. So let's change it a little bit, right? So we cut that off. So the x already has changed, right? You can see that. So now the pounder, right? It pounds the x, and so it must change its appearance, right? And let's move it a little bit on the other side. So it's now watered, right? So maybe we can say that now it's kind of a little bit blue, right? And at the end, right, the x comes out, right? And now we call this thing here that is no longer x, right? We call it like y, right? And we say something like y equals this thing here, what comes out, right? So we name it y, and so the x here is no longer there, right? It went through the machine, and now we have the outcome, which is called y, and y is equal to the thing that comes out, actually, right? And so this is a simple explanation of the function, right? You can have the machine, we call it f, right? And you can have many different machines, right? So this is just one machine, but you can have completely other machines. So let's look at another one. Let's look at a car factory. Yeah, very simple car factory. So we have our x, and the x is something like a chassis, right? So we get the chassis in, right? We just do it with the x again. So here there are tires coming, right? Tires, and then the roof of the car, and at the end you get the, let's say, like a flag that comes onto the car, right? And our x is the car, so it comes in, right? So it gets tires, it gets the roof, and it gets the flag. And maybe it looks something like that now. So we have tires, we have the roof, and it has a flag in the end, right? And the end product, we call it again y. Y equals this thing here, right? So what happens is basically you have in the beginning an x, then you have the machine that's called f. The machine changes the x, and then you have an end product, and we call it y. And what happens is that the x through this machine f is assigned a y, right? And this is basically what a function is doing. And a mathematical function now looks like that. But this is the basic idea of a mathematical function. So let's look a bit further. Let's have an x and let's have a function. We call it f. And we do the following. This function here, this machine, just adds +2 to the x which comes through the machine. So the x comes, right, again, comes here, it gets a +2, and then the whole thing is coming out of the machine. And then we name the end product y. And this is why also y equals x plus 2, because now it's the same thing, right? Y is just a name for this end product, and they are forced to be the same with the equality sign, right? Even if they are not the same on the left and the right, it forces the equality sign, says yes, y and x plus 2 means the same thing. Okay, this was an example how to create a very simple mathematical function. Let's look at another one. We have our x again. We have our machine. We can call it also f. In most cases, the machine is called f, the function is called f, but we could also use like f1 or f2, but in most cases, it's just f, and this is totally fine. So let's see what we could do also. We could square it, and we could have a machine, a mathematical function that squares whatever comes into the function, and it adds also +2. So what happens is, like the x comes into the machine, it gets the x squared, and it gets the +2, right? So let's do that, let's try that. I hope it works out as I'm trying that. So you have the x squared, right? And then it gets the x squared gets the +2, and then the 2 come out, right? And so now again we name this outcome y. Y equals x squared plus 2. Let's make it a little bit more clear, like that. Now it's very clear, right? So this is how you do that. And you can do that also with cubic functions where 3 is here. So let's do it. F x raised by the power of 3, raised by the power of 2, and you add 2. So let's do that. X comes in, x raised by the power of 3. Then you need another x, because then we need another one that is raised by the power of 2. And then the whole thing gets a +2, right? So let's try that again. So we have x raised by the power of 3. Then we get another one, x, put it again here. We raise it by the power of 2. And the whole thing here now comes out of the machine. If I can get it out of the machine, yes, I can. And now it looks like that. And we have something like y equals, and now make it a little bit more clear that everyone can read it. X raised by the power of 3 plus x squared plus 2. So again, what we had was, we had an x, right? And the x went through the machine, f, and this is the outcome when we had another x introduced and went through the machine, and it became +2. So this is how you can think of creating a function, and there are infinitely many functions in the parallel world. Parallel world idea is from the start video. Watch the start video. I put the link for the start video in the description. So now we are coming closer, because now it gets more concrete. Let's look at this function here, because our goal is, we have our x, right? And we want to not only have an x going through the machine, but we want to have a specific x, let's say this is x is equal to 2. So what happens is then that this machine here we duplicated. We said we want to raise it by the power of 3 and want to raise it by the power of 2 and add 2. So we said that x equals 2, right? So x and 2 means the same thing. So 2 and x, you can interchange them. And this is from the variable video again, the idea. And what happens now is the 2 is like the x before, is coming into the machine. It gets a raised by the power of 3 plus raised by the power of 2, and it gets this plus 2 also, right? So what happens is that, let's do it again. We have 2, right? You have to duplicate it. It gets a plus is also added here, and we get also the plus 2, right? So now we get the whole thing from the machine, and right, that's difficult a little bit, and get it out, right? And again we call this y equals 2 raised by the power of 3 plus 2 squared plus 2. Let's write it in a good way. 2 raised by the power of 3 plus 2 raised by the power of 2 plus 2. And now we have to calculate it. And this is 8. 2 raised by the power of 3 is 8 plus 2 raised 2 squared is 4 plus 2, and this equals 13. So what happened was, we had this x squared, right? We put it into machine, raised by the power of 3, raised by the power of 2, plus 2. So it went through the machine, and this was the outcome then. So what happened was, we just had the number 2, and it is assigned now to the number 13. So again, this was a simple way, and now we come to the mathematical language, yeah? And mathematics, we write it in a different way. So we have f of x equals x raised by the power of 3 plus x squared plus 2. So now it looks different, right? So before we had the machine here that we have to name f again. And this was inside of our machine, right? So this was what happens with the x inside of our machine. So this is the input value, x. It was always in front of the machine. Then we have the name of the machine, which was on top of the machine. And then we had the rules, what has to be done inside of the machine. And this was done inside of the machine, right? The red, what I've marked red here. So it's just a different way of writing it out of convenience. So you put the x in, and then you look what you have to do with the x. The x has to be cubed, squared, and there has to be a 2 added. And for x, we have plugged in this value 2, right? We do it in the same way. F of 2 equals 2 raised by the power of 3 plus 2 raised by the power of 2 plus 2, right? And there comes the same result as above, as here, right? There's no difference. It's just a different way of expressing it. And the most important thing is that still f of x means, and this is important, it means y, right? You can write a y in front of it. Y equals f of x. It's just a different way, f of x, of writing y, or the other way around. You could easily write here also here at the end you could write y, because when you have an equation, it goes from here to here. So y equals y is a true statement, and it goes from here to here. Y equals y is also a true statement. And you could write, for clarification, you could also write y here, because this is what is done, right? You have this x value and it is assigned a y value, and our x value is 2 and our y value is 13. So, but as we know from school, this is not done, right? It just for the sake of argument, I wrote this now to make it more clear. But this is very important, that you always have to keep in mind that y equals f of x, and the writing now is not like this, as we had it above with the machine. So f, and then y, right? So you have x, then f, then y, but it is written in this way, so that the f comes here, the x comes here, and the y comes here, right? So you write it like this. And what happens here is that you assign this 2, you assign that to 13. So you could write also as coordinates 2 for the x value and y for 13 for the y value, and you could write it in a coordinate system with x and y, and here would be 2 and here would be 13. So here would be x and here would be y, and this is why you can always do it like that and write the point where the coordinates are represented. And this is an idea from the video of the unit and the coordinate system, which is also in the description. I hope today you understood the mathematical function. Happy holidays!